Perpendicular unbalanced force problems. Doug, a dog, pulls on a wagon that has a weight of 33 newtons. There is a 25 newton force of friction that acts on the wagon, but Doug pulls it to the left with a force of 40 newtons. What is the acceleration of the wagon? Let's start with a force diagram. The wagon has a weight of 33 newtons. That means the force of gravity by the earth on the wagon is 33 newtons downwards, so negative 33 newtons. The force of friction is 25 newtons. The wagon wants to slide to the left, so the force of friction will act to the right. So the force of friction by the ground on the wagon is 25 newtons. Doug pulls it to the left with a force of 40 newtons. He's wearing a harness, so we'll say that's a force of tension to the left by Doug on the wagon. And because it's leftward, it'll be a negative 40 newton force. The normal force by the ground on the wagon will be upwards because that's perpendicular to the ground. The wagon is free to move from side to side. However, it won't move up or down, so there's no vertical motion, which means the net force in the y direction is 0. The forces are balanced in the vertical direction. We know there's a force of gravity. We know there's a normal force. We know there's a force of friction, and we know there's a force of tension. So the force of gravity acts downwards, so there's no horizontal x component. The normal force acts upwards, so there's no horizontal or x component. The force of friction acts to the right, so there's no vertical or y component. And the force of tension acts to the left, so there's no vertical or y component. We know the force of friction is 25 newtons to the right, so that's positive 25 newtons. The force of tension is negative 40 newtons because it's to the left. The force of gravity is negative 33 newtons because it acts downwards. The net force in the y direction is the sum of all the vertical forces. So in this case, the force of gravity plus the normal force. The net force in the y direction is 0. Force of gravity is negative 33, so the normal force is 33 newtons upwards. The net force in the x direction is the sum of all the horizontal forces. In this case, it'll be the force of friction plus the force of tension. So the net force in the x direction is 25 newtons plus negative 40, which is a total of negative 15, which means it acts to the left. But what we're looking for is the acceleration of the wagon. So we know from Newton's second law that acceleration is proportional to the net force and inversely related to the mass. But we still don't know what the mass is. Lucky for us, the force of gravity is calculated using mass and gravitational field strength. We know the gravitational field strength is 9.8 newtons per kilogram, but we can round it to 10 newtons per kilogram. So the force of gravity was negative 33 newtons equals mass times 10, so the mass is 3.3 kilograms. This equation calculates the magnitude of the force of gravity, so we know that the mass is positive. The acceleration in the y direction is equal to the net force in the y direction divided by the mass. So negative 15 newtons divided by 3.3 kilograms. We find that the acceleration in the y direction is negative 4.55 meters per second, and that negative sign means to the left. A hot air balloon uses hot air to create buoyancy and upward force by air on the balloon. The hot air balloon to the left has a mass of 450 kilograms and is accelerating upward at 1.8 meters per second squared. What is the buoyant force acting on the balloon? Let's start with a force diagram. Buoyancy creates an upward force by the air on the balloon. So FB by air on balloon. We don't know what that buoyant force is. There's also a force of gravity by the earth on the balloon. We know the force of gravity is mass times the gravitational field strength, which we can abbreviate as 10 newtons per kilogram. We know the mass is 450 kilograms. So the force of gravity will be 450 times 10. So the force of gravity is negative 4,500 newtons. The negative means down. We know there's a force of gravity that acts downwards. This means it has no horizontal x component. The buoyant force acts upwards, so it also has no x component or horizontal component. The net force in the x direction is the sum of all the x components of the forces. So the force of gravity plus the buoyant force. Both of these are 0, so the net force in the x direction is 0. We know the force of gravity in the y direction is 4,500 newtons, and that's downwards, so it's negative. We don't know what the buoyant force is, and we don't know what the net force is. Usually we can add up the forces to figure out the net force, but if we don't know all of the forces, we'll have to find the net force in another way. Luckily, Newton's second law tells us that acceleration is proportional to the net force and inversely related to the mass. We can rewrite this as the net force equals the mass times the acceleration. So the net force in the y direction would be 450 kilograms times the acceleration, which is 1.8 meters per second. It's upwards, so that's why it's positive. The net force in the y direction will be 810 newtons upwards, so positive 810 newtons. In order to figure out the buoyant force, we can use the net force equation. The net force in the y direction is the force of gravity plus the buoyant force. 810 equals negative 4,500 newtons plus the buoyant force. So our buoyant force must be 5,310 newtons.